Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, AI economics, an executive playbook for budgeting, measuring, and optimizing AI spend. If you run engineering, data, or finance in a company that relies on models in production, this episode is written for you. Here's the promise. By the end of this episode, you'll have a concrete set of steps to build a 90-day cost validation experiment, a template for an AI spend dashboard for your executive team, and practical levers to reduce unit cost without destroying product value. This matters now because AI costs are recurring, compounding, and too often invisible until they're a crisis. Less hype, more impact.
To make this practical, I'll speak from a composite profile you'll recognize. Imagine a chief data officer at a large enterprise, retail or financial services, running a 120-person data organization, 40 production models, and a multi-cloud footprint. Monthly inference costs are non-trivial. Retraining cadence is weekly for some models, and cross-functional stakeholders expect feature velocity. The CDO owns outcomes and is accountable to the CFO for both value and spend.
Operational context. Data pipelines ingest billions of rows daily. Feature stores power real-time scoring for customer-facing systems, and a mix of third-party APIs is in use for specialty capabilities. Teams are split between core ML engineering, platform, data engineering, and analytics. The pain points? Unexpected cloud bills, unclear ROI per model, and a creeping operational tax from monitoring and retraining. Sound familiar? Good. That's what we'll fix. First core concept, AI unit economics. Unit economics is how much it costs to deliver a single unit of value, a prediction, a personalized recommendation, a fraud decision, versus the incremental revenue or cost avoided by that unit. Define the unit that matters to the business before you do any deep cost modeling. Is it a qualified lead, a prevented fraud event, an upsell enabled? Keep it simple. Once you have the unit, break down costs into 4 categories: inference, training, data engineering, and organizational overhead. Inference includes real-time compute, model serving, and CDN or caching costs. Training covers GPU hours, experiment runs, hyperparameter sweeps. Data engineering is storage, ETL, feature pipelines, and feature store ops. Organizational overhead is people, platform maintenance, monitoring, and compliance. Estimate each bucket conservatively. For inference, compute requests times cost per request gives a baseline, but don't forget supporting infrastructure, load balancers, logging, and observability. For training, capture not just the final training run, but the full experiment lifecycle, prototype runs, failed experiments, and hyperparameter searches. Include a recurring line for model monitoring and retraining. That's where budgets routinely undercount. Now, unit cost math in practice. Suppose a model serves 1 million predictions monthly, and the monthly inference bill is $60,000. That's 0.06 cents per prediction. If each prediction delivers 0.50 cents expected incremental margin, the unit economics look healthy. But do sensitivity analysis. What if traffic doubles? What if model accuracy degrades and value per prediction drops 20%? Build a 3-point estimate: best, expected, and stressed, and use that for planning.
Prioritization framework. Tie features to value density. Value density equals expected business value per unit divided by incremental cost to implement and operate. Rank experiments and features by value density, then layer in strategic importance and risk. This avoids the trap of optimizing lowest cost features that add no real customer or business value.
Trade-offs are inevitable. Latency versus cost is a classic. Real-time low latency scoring might cost 10 times more than batched scoring. Ask, does the business actually need that latency at scale? Can you degrade gracefully,
fast cached responses plus asynchronous enrichment. Similarly, accuracy versus compute. A 1% AUC improvement can be expensive. Measure marginal value of that 1% in dollars, not in model metrics alone.
Tactical levers to reduce cost without killing impact. Model distillation to get similar accuracy with smaller models. Batching and vectorizing requests to reduce overhead. Smart caching for queries with repeated patterns. And hybrid architectures, where a cheap model routes easy cases and a heavy, expensive model handles edge cases. Consider mixed precision inference, optimized runtimes, and auto-scaling policies tuned to avoid over-provisioning. Vendor strategy matters. Negotiate for committed scope discounts for predictable workloads. Use spot instances for non-critical training, and insist on transparent billing from vendors. Be wary of black box APIs with per-call pricing. They are convenient, but can be runaway costs at scale. Always include a migration plan so you aren't locked into a vendor with escalating spend.
Next section, leadership and organizational levers. Who owns AI spend? There's no single right answer, but clarity matters. Centralized funding works when you need platform investments and shared infrastructure. Chargeback or internal showback works when you want teams to feel the marginal cost of decisions. A common hybrid is platform funded centrally, marginal inference costs shown to product teams, with pilots using chargeback to align incentives.
Dashboards for the C-suite should show simple, comparable metrics. Total AI spend, spend by model or product line, unit cost trends, value per unit, payback period, and the top 3 cost drivers. Avoid raw technical metrics that confuse executives. Pair each cost item with the outcome it supports, revenue, retention, or cost avoidance, so conversations stay outcome-focused.
Measuring ROI and engineering productivity. Move beyond lines of code and model count. Track value delivered per engineer month, feature cycle time adjusted for impact, and cost per experiment. Create a lightweight scorecard that captures time to impact for features, and tie bonus or recognition programs to business outcomes, not just model performance. This shifts behavior toward efficient experimentation.
Procurement tips. Involve procurement early for long-term commitments. Push for unit-based pricing where possible. And bake in termination and export clauses so you can move models or data if economics change. For large vendors, negotiate usage tiers and SLAs that reflect realistic traffic patterns rather than optimistic forecasts where you pay for unused capacity. Looking ahead, risks that quietly drive cost. Technical debt from brittle pipelines, model proliferation with many single-use models, and ad hoc retraining schedules all compound. Create policies that cap model sprawl, regular model reviews, a life cycle for decommissioning, and a mandatory cost-benefit justification for new production models. Make monitoring and retraining an explicit budget line in forecasts.
Resilient budgeting practices. Use rolling forecasts. Keep a contingency for unexpected retraining or incident recovery, and conduct quarterly cost stress tests. Prepare finance and legal for recurring commitments by translating technical cadence into predictable line items. For example, quarterly model refresh budgets, monthly inference baselines, and annual platform maintenance. 2 actionable next steps you can run this quarter. 1. Build a 90-day cost validation experiment. Pick one high-cost model, map its full cost profile, run sensitivity tests for traffic and accuracy, and validate the real unit economics. 2. Create an AI spend dashboard for the exec team with 3 key metrics: unit cost, value per unit, and payback period. Share it monthly and use it to prioritize investment. Final reflection. Managing AI economics is not a one-time exercise. It's continuous discipline, defining units, measuring costs honestly, prioritizing by value density, and embedding accountability in funding models. When you translate model decisions into dollars and outcomes, you cut through the noise and direct investment where it actually moves the business. That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact.
Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.